Okay, so now we're going to talk about how do we solve an absolute value equation. And I'm hoping this is going to be review for most of you, but it's a good review to kind of go over. We talked about how do we graph inequalities and things like that. And not only are we going to be graphing or solving absolute value equations, we should also have in here, we're going to be looking at equalities as well. And so it's a little bit more difficult to do, just slightly more difficult for an inequality than it is an equation. So we're going to do absolute value inequalities and equations. So there's a little difference. We've been working on graphing so far. Solving is just finding the solution, and graphing is when we kind of show that solution graphically. All right. So there's a little difference where here we actually want to know, well, for what values x can I put in where I get out an answer of 10 when I take x and add it to 5, take the absolute value of it. All right. So absolute value, and we can even kind of go back a couple things here to say, okay, what is an absolute value? What numbers have a distance away from 0 of 3? All right, so all the numbers. Well, for this one, there's two answers. Both positive 3 has a distance away from 0 of 3, and negative 3 has a distance. So x could either equal positive 3 or x could equal negative 3 here. Both of them are a distance of 3 away. Both of them, when you take the absolute value of them, you get 3 for an answer. So that's the idea that we have to use here is what's ever in my absolute value here, whatever was here in the taking the absolute value, it could have originally been a positive 10, and then when I took the absolute value, I got a positive 10, or it could have been a negative 10 in here, and when I took the absolute value, I got a positive 10. So you kind of have to look at two scenarios here, that either x plus 5 equals a positive 10 or x plus 5 equals a negative 10. Now in this case, we're going to take away 5 from both sides. We're going to solve this equation, and indeed x would equal 5. In this case, we're going to take away 5, or subtract 5. I don't know why I put 15. Sorry about that. Minus 5 here. And here, x would equal a negative 15. So this is a situation where x could either equal 5 or negative 15. They have two answers here. So when you're going to say, okay, what are my answers? You actually have two of them. Now, what our plan is here is when we have an equation that has an absolute value and something else is happening, an inequality, let's look at kind of, we're jumping real quick into inequality. And this works whether there's an inequality or an equation. If you have, you need to wait before we look at the two options here, before we kind of split it up into two parts here. Sorry about that. Ooh, went flying away. You have to first have just the absolute value on one side of your inequality or equation. So the first thing I would need to do for this problem here is I needed to add 5 to both sides of my equal sign, okay? Then I got this, that x minus 2 must then be less than 9. So now that we don't have, if we had an equal sign, this is what we would do. We would say x minus 2 equals a positive 9, and x minus 2, sorry, I can't write again, equals a negative 9, and we'd be done. But we don't. We have an inequality. So now what you're going to do here is you're going to do an as is, exactly as it's written here. X minus 2 is less than 9. And then what happens is, as you go and you say, okay, we're going to have it be a negative, it actually switches your inequality. So you're actually going to have to switch your inequality for your second kind of case, second scenario that you're messing with. So we have x minus 2 is greater than a negative 9. So we need to solve this one. So we're going to add 2 to both sides to solve this one. And then x would be less than 11. Adding 2 here to solve this, x would be greater than negative 7. So x is greater than negative 7, but at the same time less than 11. So we can write it all in one thing here, that x has to be greater than negative 7 and less than negative 11. So it's between the two. We could have graphed it to kind of decide, are we between two of them? You can kind of look as the x's, is it going toward and away from the x's at the same time? It kind of just depends on the problem. Like this would be our -7, here would be 0, here would be our 11. And that we were talking about anything below -7. So this is actually an and, not an or. So it's this the other one we had or, it was this number or this number. This is an and, that x has to be less than 11 and greater than -7. Whenever you start with a negative or a less than here, you're always going to get an and. They're always going to go toward each other. If you start with a greater than symbol, you would have an or in the end, and we'll show you kind of what that looks like here with this one. So remember this one when we started with, oh, we have another less than. That's okay. We'll solve this. So reminder. Okay, this was a good reminder here. Whenever you're dealing with negatives and inequalities, positives, negatives, and inequalities, you have to remember about the rule that switches your inequality. And let me give you an example of that. So for this problem, I would solve this by starting by adding 2 to both sides. Adding and subtracting never switches an inequality. So we're okay so far. But then here, to solve this, I would want to divide both sides by a -3. When you divide by a negative, it switches your inequality. And hopefully you've had that before, you've worked with that before. So be careful of that. Watch out for when you're dividing by a negative value that your inequality will switch. So now here's what I want to do, a greater than symbol, okay? So x plus 6 is greater than 4. So either you write the first one exactly as it's seen, x plus 6 is greater than 4, or you write the first part, x plus 6, and you switch the inequality, so it was greater than here, I made it less than, and you make it a negative value here. In this case here, I'd subtract 6 from both sides, and x would be greater than -2. In this case, when I subtract 6 from both sides, I get that x is less than a -10. Now, if we think about, okay, how does that look when we graph it? Here's -10, and here's -2, and here's 0. So anything for -10, it's still less. So it's this direction that we'd be talking about, and it's still greater than 2. So it'd be like in this direction. So this one is an or. It has to be this or this. So it can't find a number. There's no number that can fit in both of these ranges. So it either has to be one or the other. So when you're kind of done with the shading, if the shadings go toward each other, it's an and. If the shadings are going to go away from each other, and you can see these are going away from each other here, it's going to be an or. Okay, let's look at another one. Some problems from your assignment for today. So we'll start with, I'm going to just pick this one here. We already have just the absolute value on one side of the equal sign. So our problem here would be set it equal to exactly as is, as you see it. And then the other problem, what if what was in between the absolute value sign was negative? So we leave it at a negative. So in this case, excuse me, I'm going to subtract 12 from both sides. And my a would equal 21. There we go, I got my math right there. Subtract 12 from both sides here. And my a would equal -45. All right, let me get one with an inequality. I don't know, I thought I had some. There's some with an inequality. Let's talk about, 11. It's such a good problem. First thing I'm going to need to do with 11 is I need to divide each and every term by 3. So now I have this, 2a plus 7 equals a plus 4. Now I need to switch it. All right, now I need to kind of do this to it. How do I switch it? Okay, well, before what I was doing, I didn't have an a in the equal sign area, but that's okay. We're not going to let that throw us off. So what we did, just exactly as we saw it, 2a plus 7 equals a plus 4. And then we said 2a plus 7, and then you just have to make it the opposite sign. So technically this is what I did here. I did this, a plus 4, and it was the opposite of it. So I subtracted both the a and the 4. In this case, to solve it, I'm going to take away an a from both sides. And so then I'm going to have a plus 7 equals 4. Take away 7 from both sides, a would equal -3. In this case, I'm going to add an a to both. Oh, you know what? I just realized what I did wrong. No, I did right. I'm going to add an a to both sides. So now I have 3a plus 7 equals -4. Subtract 7 from both sides. 3a equals -11. A would equal -11/3. Don't get worried if you get a fraction. Fractions can be our friends. Okay? Let's look at another one here. All right, I'm going to look at 18. A little bit tougher problem. Let's look at 18 here. So 18. First thing I would need to do is I need to kind of take this minus 3x and I need to get it on the other side of the inequality, because before I split it up into two parts, I have to have just the absolute value on one side of my inequality or equation. So adding 3x's to both sides does not change my inequality. So I have that, and it doesn't change my inequality here. Now I have to think of it as two separate cases. One kind of as is without your absolute value sign, and the other, you switch the inequality and you make it the opposite sign that when you set it equal to it. In this case here, though, if I take away 3x's from both sides, I get the 4 is greater than or equal to 0. And while that's a true statement, it doesn't help us. So basically, we get no solutions from that. And actually, what it turns out to be is infinite solutions. That no matter what, you're going to get a solution there. So you have infinite solutions. Over here, if I add 3x to both sides, I get 6x. And if I bring this over here, you get this. Oops, sorry. And so it ends up to be -2/3. But hey, we already got infinite solutions. So we already found that no matter what number I put in here for x, I'm always going to get a right answer. Positive or negative, it's always going to be the right answer in the end. It's always going to be greater than whatever 3 times that is. So your answer in the end is just this infinite solution. So there's times where you're like, yep, no matter what, you're going to have a good solution. Good luck with it. You know what? I'm going to pause it. I'm going to do a couple more, and I'll let you see the answers. All right, so I worked out 13 and 15 for you here. One thing you'd notice is actually this one here too. X should be greater than or equal to -1. Both of them are less than, so they start off with the less than, so they're ands at the end. So you kind of say, oh, it's in between. It's in between these two numbers. It's in between 5 and -1 here for 13. It's in between 7 and -2 for 15. The big thing here is in both spots, I had a part here where I was dividing by a negative. And when you divide by a negative, if you notice, I switched my inequality. Here I was dividing by -2 in both spots. So there is some inequality switches. Good luck and have fun doing the assignment.